Okay, so are you guys able to hear me?
Yes.
Yeah, yes, Geetha.
Okay, cool. Okay, so I'm going to talk about, first of all, thank you for attending the Spark tutorial or whatever. So we're going to talk about Spark today. Introduction, like basic introduction on Spark. So Spark started off as an open source cluster computing framework. It originated at University of California, Berkeley at their AMP lab. And later on, the project got donated to this Apache Foundation and it became open source. So that's a really cool thing. So Spark is now open source. So in Spark, the main abstractions are something called RDDs. RDDs are like they are resilient distributed data sets. So you can think of them as a collection of elements that are like partitioned across machines in a cluster, and you can perform your operations on these RDDs in parallel. The RDDs are resilient because no matter how many transformations you do on these RDDs, how much you compress them, you can still get your RDD that was at the beginning of your program. So it will never get destroyed. RDDs will persist in memory, so they're called resilient. And also another concept in Spark is something called Spark context. This Spark context is a main entry point into your Spark program. Basically, you can think of this Spark context as a sort of like a connection string. So it represents a connection to your Spark cluster, and you can use your Spark context to create more RDDs or accumulators, which are like counters in Hadoop, or broadcast variables, which are like variables which are like global variables that that driver program will send to each machine in your cluster, and these broadcaster variables will be available for each machine in the cluster. So one of the key points to note is you can only have one Spark context available active at any time in your JVM. And if you want to create another new Spark context, you have to stop your existing Spark context. And you can create your new Spark context using this syntax. So you need to create an object of your Spark context and then pass in your Spark configurations as an argument to the Spark context. So basically you are initializing your Spark context via constructor, and you're going to store the object in something like val sc. So in Scala, there are like two types of data types you can use. You can use val and var, var. And since Spark, in Spark the RDDs are immutable, it is given that you create whatever RDDs you create, they have this val data type. So let's look at this diagram. So like if you want to work with RDDs, first you're going to create your Spark context object, and let's say you call it SC. So the first thing is you need to create your RDD. So to create your RDD, you could call this function called text file, and then pass in your path to your data on your file system like HDFS or your local disk. And once you call this function, the RDD is created, and the RDD name is going to be text file, because that's what this diagram shows. Okay, once you have this text file RDD, then you can perform two types of operations on it. You can perform your transformations or actions. So transformations are just like any type of ETL transformations you have experienced with, such as like filtering, adding new columns, things like that. Actions are something like count or first function or collect function. Basically, in Spark, you can build a pipeline of transformations So you first, on your base RDD, the text file RDD, you can do some sort of filtering on it. Then on this new RDD, you can add a new column. So like this, you could build a pipeline of transformations based on your initial RDD and create a bunch of downstream RDDs. And then at the end of your program, you could perform an action on this downstream RDD, such as count function. One of the things to note with Spark is that Spark uses lazy evaluation, which means nothing's going to be evaluated until you perform some sort of action on it, such as like count function or first function. When you perform an action on an RDD, that's when the Spark program is going to pull the required data sets from across the machines in your cluster, and then it's going to perform the action on these data that it fetched from different machines. So in Spark, you have an ability to trace back the lineage of transformations at any point in time, because an RDD at its basic abstraction level is immutable. So you start with an RDD, you transform the initial RDD to create a downstream RDD, and then you can keep on going. You can keep on using different transformations to create a bunch of transformation RDDs. So at the end, when you perform an action on this downstream RDD, that's when this whole pipeline of RDDs are going to materialize, and they're going to get evaluated. So like why Spark? As I mentioned before, Spark uses lazy evaluation, and the transformations are used to build a transformation pipeline, just like your ETL pipeline in SSIS or Informatica. And only when you perform actions on this pipeline, then the results will be evaluated, or you'll get the results. Another thing that is important in Spark is like caching of your data sets. Since Spark is based on in-memory processing, when you cache your data set, for example, you are working on a machine learning program, and in machine learning, you need to train your data set using multiple iterations. So when you are creating a machine learning program, you can cache your initial data set, and it's going to be used to train your model. So caching is a very powerful thing that is used in Spark. Some of the languages that Spark supports are Java, Scala, Python, and R. There are a bunch of different things you can use Spark for. For example, we can use Spark for batch processing, in which the RDDs are its core abstraction. The RDDs are used in the Spark core API and can support any of the 4 languages mentioned above. And RDDs are these low-level things that people used to program like a year ago, but now we have these higher-level APIs called DataFrames and datasets. So the DataFrames API comes with Spark 1.4 plus, and you could just read your data into a data frame, which is like a logical table, and you could just perform operations on it, just like any kind of operations on it, just like in SQL or ETL. So it's a very high-level API that's very good. It is in current usage by the clients. They just started using it this year, the DataFrames API. And this datasets API is going to be our next generation API that's going to be used entirely from Spark 2.0, which is going to be released soon, I think, in a couple of months. So the next high-level Spark API, it's going to be the datasets API. The DataFrames will have the backwards compatibility, but everyone's going to be using this datasets API. Another thing we can use Spark for is to do some kind of SQL operations on it. So for that, Spark offers their Spark SQL. It has 3 APIs, the DataFrames API, the Datasets API, and then your basic SQL query ability to do your SQL on the data on your data. Another thing that you can use Spark for is to do streaming. So if you want to do real-time streaming or low latency analysis on your data, then you can use your streaming API. There, the main abstraction is something called a DStream, which is Spark does not really do real-time analysis, it does micro-batching. So what it does is it takes real-time data, and then it sections the data into mini batches, and then it performs operations on these mini batches of data called DStreams. So if you want to do real-time, you need to look at other tools in the big data ecosystem, such as Flink or Storm. But Spark is not exactly a real-time solution. It's just micro-batching solution. Even in Spark streaming, you could use the same APIs you're using for batch processing, such as the DataFrames API, the Datasets API, or you could just use straight on SQL query. You can run SQL queries on your streaming data. The main use case, I think, for Spark is for machine learning, where you could build your pipelines and estimators. So they have 2 types of APIs that are available for machine learning, which is the ML library and then ML library. This ML library is your next generation API that's been released recently. Also, Spark supports graph processing using graphics API. Recently, there are some tutorials available online or some kind of conferences on DataFrames. That's going to be our next generation graph processing API from Spark. So right now we are using GraphX. I think the next one will be DataFrames. So Spark is continually evolving like every couple of months. So it's really important, like if someone's doing Spark, it's really important to keep up with current technology and current new API. And compared to Java, Spark is very, since Spark supports a lot of scripting languages like Scala, Python, and R, in terms of deployment, it's faster. In terms of coding, it's faster. In terms of maintenance of your applications, it's totally easy compared to writing your code in Java, which might take like 3 months. You could do your Scala code in like, or Python code, R code in like 1 week or 1 day. So it's from the perspective of the clients, Scala, Python, and R are like the key languages that a developer needs for Spark. Compared to Java, there are a lot of Java developers, but if someone has a background in scripting languages, that's where the clients are looking for. That's what clients are looking for, someone with the background in Scala, Python, or R. So if you look at the Spark pipeline or workflow, so we start with the initial RDD. If you remember the previous example, we are applying the text file function on your Spark context, which creates the initial RDD. And then we perform some sort of action on the initial RDD, such as like filter or add a new column. Then we have a bunch of downstream RDDs. So if you look at from the top to bottom, it's a pipeline of your transformations. And at the end of your pipeline on your downstream RDD, you're going to perform an action on it, like a first function, which retrieves just the first row in your RDD. And unless an action is performed on it, nothing will output to the disk, or nothing will output to a console. Nothing's going to execute, because Spark uses lazy evaluation as compared to eager evaluation. So Hive, if you look at like if you compare Spark SQL with Hive SQL, one of the advantages that Spark SQL has is this lazy evaluation. No matter how complex your analysis, no matter how complex your analytical pipeline is, since you're performing an action at the end, nothing's gonna get evaluated until the end. So Spark can do its optimizations in memory, and then it can build its pipeline. It can optimize its execution pipeline, and only when you perform an action on it, everything's gonna materialize and persist. So if you compare with Hive, or if you compare with your traditional big data tools like Hive, Hive uses eager evaluation, which means if you run your Hive QL, or like if you do like select count star, or like select a bunch of columns from a table, it's gonna create this new, it's gonna retrieve those columns, it's gonna evaluate that SQL statement, and it's not, so like if you have like a lot of SQL statements in a file, all the statements will be evaluated, so it's not efficient in terms of execution time or something. So the next couple of slides are just your prerequisites, or like how to get your development machine running. So you guys can take a look at these slides and get started on Spark. But I'm going to show you a demo of like how the Spark application runs, just to show you guys it's really easy. It's not that hard. So this is just a bunch of like getting your development environment running, like the various modes you could run your Spark application in. So let me show you a program from the start. So first I'm going to create it. The editor that I'm going to use is IntelliJ IDEA. This is the recommended editor for your Spark Scala projects. So I just create a new project. I select my application as Scala, and I'm going to use the SPT build tool to create my jar file. And then I'm going to name my project, let's say Spark DRSL. I'm going to make sure my project is SDK points to the Java version. And then I'm going to click Next or Finish. So it's going to take some time to set up your project in this IntelliJ editor. It's being loaded right now. So just like in a Java application, you have your source folder, your main folder, and then here I'm going to create my new Java Scala package. I'm going to create my package. I'm going to give it a name called net DRSL.spark and click OK. And then in this package, I'm going to create a Scala class. I'm going to call it an object. I'm going to call it sample. So this is your basic Scala program. So first you need to import a bunch of libraries to get your Spark running. So to do that, I need to first go to my project settings, libraries, not libraries, modules, and then I need to find the jar files that have Spark, where the Spark is. So the main libraries the jar files that you need for your Spark project is this data nucleus API JDO jar. You need your core jar, you need your RDBMS jar, and you need assembly jar and your yarn shuffle jar. So I'm just going to import those. All right, click OK. And then now I can, jar files are loaded here. And then I'm going to do post org.apache.spark.sql context. Then import for Apache.Spark functions. This thing is going to be context. Or like, first, let me first create a Spark context, and the libraries will be imported automatically. So first, I need to create my main function, where I just need to So first thing is I'm going to create my Spark configuration using this new keyword. I'm going to set a bunch of properties on this Spark configuration, such as I'm going to run my Spark application on my local machine without using Hadoop. So I'm going to set the standalone number of worker nodes to 4 to run on my local machine. And I'm going to set a name to my application. And now that I have my Spark configuration, I'm going to create a new Spark context. And then I'm going to pass in my Spark configuration as a parameter, as an argument to my Spark context. Once I have my Spark context, I'm going to create my SQL context so that I can run SQL operations on it or use DataFrames API. So I have my Spark context. I'm going to import the library Spark configuration. Apache.Spark.sql SQL context. So when I create my Spark context, I now have access to this variable called sc, which holds a pointer to the Spark context. And then now I can get started on my Scala programming. So let's say I want to read from a JSON file into my Spark program. I'm going to create a new data frame based on the SQL context. And then I'm going to do read.json, and I'm going to provide a path to my file. So this is an action we're performing on the data. I mean, now we're talking about the data frame, which is like higher level API. We're not talking about RDDs. So internally, the DataFrames API will convert our program into RDDs. So if you are using higher level APIs, you don't even need to care about the RDDs because they are lower level. It's just my JSON file is just simple. You have your employee ID with some key. You have this employee ID with some values. You have your project start date. You have your client location, a bunch of states in the United States. You have your project codes associated with each data. And then you have your billing amount for the project. So it's just a simple JSON file I created to show you guys a working demo of the Spark application. So it has 1, 2, 3, 5 columns. So what I did here is I just read my JSON file into this DFS variable. So now DFS is our data frame. So if you want to view the contents of this data frame, then we can apply this show function on the data frame. And then this is like an action you perform on your RDDs. That's when the data is going to be printed out to the terminal. And then you could run your program using your commands in your editor. Since this is the first time we are compiling our project, it's going to take a little while. But once your project is compiled, it's really fast, even in your editor. It errored out. I mean, I have the program written earlier, so I can just run this program. So basically, we are looking at this part of the code. So basically, we read from a JSON file, and then we call the show function on this data frame, so which just prints stuff onto your console. And so if we run it, you have your JSON data that is printed out as an output of a data frame. You have your billing amount, client location, employee ID, project code, and your project start date. But the thing is, the columns are rearranged compared to our original JSON data. So initially we had our employee ID as our first column, and then billing amount as our last column. But here it's the columns are shuffled. So let's see how we could get the columns in the same order as our JSON file. So I'm gonna, let's look at this one, this program. This is just reordering the columns. So to reorder our columns, we are just using our DFS. We are just using this data frame, and then we are doing select on it with the columns in the specified order we want. So we want employee ID as the first column, project start date as the second column, client location as the third column, project code as fourth column, and billing amount as your last column. So what it does is it puts your columns in the same order as your data, or whatever order you want. And then we can run our code on this part, and then the output is going to look like this. So now you have your employee ID as your first column, project start date, blah, 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 and then your billing amount as your last column.
So Geetha, that can be considered as a transformation, right? The select command that you have used.
Yes, that's a transformation.
Show is an action.
This is an action. Action.
So, yeah, select is this one.
Yeah, because I had shows after each chunk of code, it was printing all the tables.
Yes.
But in your actual program at your client list, you don't perform actions until the end.
Yes.
Yes.
Thank you.
This is just like any thing. And then let's say you want to filter your data based on your billing amount greater than $30,000. You can apply your transfer filter function on your reordered data frame, and then you could select your column and then say find the rows that have 30,000 where the billing amount is 30,000, and then I'm performing the show on this data frame.
There is also a transfer.
So you can change. Yes, you can change your change your transformations actions by using dot function.
Yes.
Yes, you can do it like that, or you could say like this. It's the same thing.
Oh, we call it as chaining the operations.
Yes, chaining the operations.
Chaining the operations.
Yes. So if you look at the output, you can find the table where the billing amount is greater than 30,000. It's going to retrieve those rows.
Yes.
And then let's say you want to add a new column to your data frame. Let's say you're not satisfied with the existing data. You want to create a flag. Let's say, is the employee current? Is the employee still working with us? So we could add the new column by using the function called with column. This is just like a derived column in SSIS. Derived column transformation in SSIS. Yes. So you just define your new column name, and then you could, this is your if-else statement. You can think of when as if and otherwise as else. So if your data frame column project start date contains 2003, then the employee is our current employee. So the flag is set to 1. Else, the employee is not working with our company, so let's set the flag to 0. And you could see the results of this data frame using the show function. And let's see. So this guy, employee 1205, started in March 3rd, 2003, and that's the only guy that is working with the company right now. The other ones, they left the company. So let's say you have a lot of duplicates in your data and you want to remove those duplicates. You could use a function called drop duplicates, and then you could use this syntax called like array, and then you can list your columns as a comma suffix string, and it's going to drop duplicates based on these columns. So if there are duplicates on employee ID and project start date, it's going to drop those duplicates, and then we're going to only select the employee ID. So here you're seeing this chaining on operation, or like operation chaining or something. So you're going to drop the duplicates based on employee ID and project start date, and then you're only want to retrieve this employee ID column, and then you're going to view the results. So one of the things in Scala is like you don't need to put your parentheses if you're not passing any arguments to your function. So that is equivalent to this. So let's view that data. So it only is based on our data frame query. So yeah, so in my project I drop a lot of duplicates in my data based on a bunch of columns. And another thing that is really important, which is a transformation, is to get your distinct rows. So for that, you could say your data frame dot distinct, and then you can view contents of your data frame. And then another important thing that I use in my project a lot is setting a null if something based on a business rule, like let's say if an employee worked in Illinois as a client location for a project, I want to set the employee record to null. So I want to set a flag to null. So for that, I'm going to first create a new column called derived column called is in Illinois flag. And then I'm going to set the value based on our if-else logic. If our employee current client location is Illinois, I'm going to set the flag to null. Otherwise, I'm going to set the flag to the current location. And then, so if this is a transformation, there is no action performed on this data frame. So let's say I want to save the results of this data frame, the data frame called DFS underscore is in Illinois flag. This is the name of the data frame. Let's say I want to save it to the disk. I could perform an action on it. So this is our data frame. You need to convert our data frame to an RDD, and then you apply the save as text file action on your RDD. So there are limited cases when you're using data frames where you use RDDs. One of the instances is when you want to write to the disk. You convert your data frame into an RDD, then you apply your RDD functions on the RDD. And then I provide the path to my save as text file function. And when I run it, when I ran it before, I believe it created an output folder. So we have two part files that are created because I guess the default partition was two partitions when it was writing to the disk. So in one partition we have a bunch of data associated with our text file, and in another partition we have another set of rows that are associated with our data frame. But when you, like, let's say you move these part files to Hadoop, and then you want to run your it's going to consider these part files as just one set of files. It's like there's no difference if you have multiple partitions. So at the end of your Spark program, you need to stop your Spark context because if you keep your Spark context open, then other people cannot create their Spark context, new Spark context. So it's a good thing to stop your Spark context so that you exit cleanly from your program. So after your program executes, the control gets back to the terminal or whatever. This is a simple Spark program for batch processing. So if you don't, let's say if you don't, let's say remove this show function. Oh yeah, another thing that's really useful in Spark are these window functions, aggregated window functions. For example, you wanna do a min over a partition of columns. You can use the syntax like this. So you first create a new column. Let's say we call it min billing amount, and then to calculate values to append values to that column, you could, let's say you want to do a min function. You do min data frame column DFS reorder billing amount over window.partition by your employee ID, project start date, and your client location. So what it does is it's gonna look across these partition columns, and it's gonna append the same min value to each entry in that partition. So in my project, I do a lot of aggregated window partitioning in my code. And so aggregated window functions are really useful to know in Spark. But the thing is, you cannot do count distinct over a window function in Spark. That's one of the disadvantages. But you can do sum over partition by, max over partition by, count over partition by, like bunch of standard aggregated window functions.
Do you have ranking functions also, Geetha, in the Windows?
Yes, ranking functions are available.
Rank and dense rank.
Yes. So in Spark 1.4.1, you do not have the capability for statistical functions,
okay,
like standard deviation, variance. So you need to do math calculation yourself and build the function.
Okay.
But in the next versions of Spark, there is a support for statistical functions.
Okay.
You can do standard deviations, variance, variance over partition by. I think you can do those too.
Okay. Thank you.
Yeah. So it's really easy. The DataFrames API is really easy. It's just like, you can think of it like an ETL pipeline. You can just think of it like ETL.
Yeah, it appears like some ETL features and SQL features.
Yes, it's a mix of both.
Mix of both SQL and ETL. Yeah.
Yes. So the next Spark API is the DataFrames API, and that one, it uses more Scala features.
Okay.
Like typecasting, those kind of things. DataFrames API is just a mix of ETL and SQL.
Okay.
So it's not. I think this is like similar to like our language, or like working on a data frame level.
Yes. Yes.
Yeah, it's not that hard. So I don't know, like, why not many people are getting into Spark. I don't know. Maybe they looked at RDDs and got scared off. I don't know. Okay. Yeah, I will send you this sample program so you guys can look at it, and then I will also send another sample program based on my current project.
Okay.
So you guys can have a real-time, like, you guys can have view on like how it is being implemented at the client place, what are like how it's being deployed to the clusters and things like that. Real-time view on the project.
Yeah, that is more required for us.
Yes.
Yes.
So I'm still like working on that, like putting everything together, but documentation part. But I think I will send it once I have it done.
Okay.
Yeah, sure. Thank you.
No problem. So does anyone have any questions or?
No. Thank you very much. We were actually looking for some support. Thank you very much.